Hello guys, welcome back to the online video training session of NSCAN. My name is Saurabh Kulkarni. So in today's tutorial we'll see some of the topics. So in first we'll see how we can import the CAD model into the NX software. Then we'll see how to create the stock. Then we'll see how to create the fixtures. Then we'll see how to go into the manufacturing workbench. Then we'll see how to set up the model. Then we'll see how we can create the tools. Then we'll see how to create the operations. Then we'll see how to call the machine tools. Then after that we'll see how to simulate the program. Then we'll see how to create the part program. Okay, so this is my operation sequence. Then come to this model. So I have this model, so we have to create the part program for this model. So you can see we have to perform the operation on the top surface as well as on the bottom surface. So we'll see how we can create that. So the operation sequence, this is my operation sequence. So first open the NX software and we'll see how we can import that. So just click on new, click on this new option. Then go to this file menu, just click on import, just select the step format. If you have the file in another CAD format, just select that format, just click on OK, select the file and click on OK. It will take some time. So you can see in the status 100% is completed. So now the model is imported. Okay, so this is my model. Then we'll see how we can create the stock. So to create the stock, just click on extrude, select the face and select the rectangle, create the rectangle here along its periphery. I want to leave some stock at the bottom, so for that I'll just click on minus, I'll just set the value -30 and on the top I'll just specify 120. In the boolean operation, make sure that your none option is selected. If you select the unite option, so it will automatically merge your workpiece with your stock, so you will not get access to select the workpiece and stock separately. So for that just specify the boolean operation type as none, then click on OK. Then I want to see the inner part, so for that I'll just change the transparency of external part. So just select this external part, click on Ctrl J, then change the transparency. So in this way I will just change the transparency. Now I have to apply some fixture. So for that just again go to the extrude. So for this model we'll hold this workpiece in bench wise. So for that I'm just creating the jaws here. So this is my jaw. Click on finish. Specify the 0 value here, then 50. So this is my chuck. Again the boolean operation type as none, just click on OK. Then I want to mirror this object to the other side. So for that I want some mid plane in this section. So for that just click on datum planes option. From the type select the bisector. So select the first face, select second face. It will automatically create the mid plane. Then select this extrude and go to the more option, just click on mirror geometry, select the mid plane, just click on OK. So now you can see we have imported the model, then we have created this blank, then we have created the chucks. Okay, So we'll just create some groups for that. I'm just selecting these three, right click, feature group, name as clamps, then I'm just giving the name as model 1 top. Okay, I just specified the feature groups for the simplicity of selection. I'll just hide the plane, diagram plane. Okay, then in this way we have set up the model. Then next step is to go into the manufacturing workbench. So to go into the manufacturing workbench, just you can go by the shortcuts, that is Ctrl Alt plus M, or you can go to the application, then click on manufacturing. Then you will come to the manufacturing workbench. Then machining environment window will open. So in CAM session configuration, select the CAM general, and in the CAM setup select the mill planer option and click on create. Then we have follow this same procedure. Now the next procedure is that the machining formula. Okay, before whenever you come into the manufacturing workbench and any software, we have to follow this formula MWSOP. So what is that? M stands for machining coordinate system. So whenever you will come into the manufacturing workbench, the first step will be setting the machine coordinate system. So we have to specify the MCS. So we'll just specify that. So to specify the MCS, just go to this geometry view option, then double click on this MCS mill, select the CSYS dialog, and just select the point. I want to specify my machine coordinate system to this point, so I'll just select this point and just click on OK. So in this way we have specified the machine coordinate system. Then the next step is to specify the workpiece. So for that, just again go to this NX window, then just open this and double click on this workpiece. Here specify the part. So I want to select the inner portion of it, so just move your cursor here and right click, select from list and select the inner portion and click on OK. Then specify the blank. Just make sure you type as geometry and just specify this blank. Then click on then next step is to we have to specify the fixtures. So if you specify the fixtures, then machine will automatically detect this as a non-cutting area and it will avoid the tool path to come in contact with these fixtures. So in this way we have done the setup. So we have followed this formula. So first we have specified the machine coordinate system, then we have specified the workpiece, then we have created the stock. Then the next step is to create the operation sequence. But before that, I'll show you how you can create the tools in NXCAM. So in NXCAM, there are certain tools are available in software, so you can recall that tools and use that tools for operations, or else you can create your own tool by your own configuration. So I'll just show you both. So to create the tool, just click on this create tool option. Select if you want to call the tool from software, so just select this retrieve tool from library, then select the operation type as mill, then just specify the diameter as 20. You can see in the software there are 5 to 6 tools are available of 20 mm diameters of different configuration. Okay, so if you want to select any tool from library, just click on OK, or else I'll show you how you can create the tools. Just click on cancel, then select the tool subtype as mill, then give the name and mill cutter of 30 mm diameter. and just click on OK. Let's specify the diameter here 30. If you want to specify the shank, just click on the shank and just click on define shank, so it will create the shank. If you want to create the holder, then you can create the holder here. But if I don't have any dimensions of holder, so I will not create that. I'll just simply specify the tool number 1 and just click on OK. And again I will create another tool that will be end mill cutter of 10 mm diameter. Click on OK. Just specify the diameter here and just specifying the length. Then tool number should be 2 and click on OK. So in this way I have created the 2 tools. Now the next step is to create the operation. So for that, just click on this create operation window. From that type, select mill planar, and operation subtype should be planar mill. Then I want to cut the workpiece, so in geometry select the workpiece, then click on OK. This mill planar window will open. In this we have to specify the part boundaries. So how much material we have to remove, so we have to select that. I want to select this inner face, so but it is not highlighting, so for that I will just right click on this, click on select from list, just select this inner portion. Okay. Similarly select the other faces. So in this way I have selected these faces, then click on OK. Next we have to specify the blank boundaries. So this transparent part is my blank, so we have to specify the blank boundaries. So I'll just select this face and click on OK. Now specify the floor, up to how much depth we want to cut the material. So I'll just select, right click, select from list, so I'll just select this as my floor. Means operation will start from this top of this blank and up to this floor. Then again we have to specify the tool, so we have to specify the tool. I'm selecting the end mill cutter of 30 mm diameter. Then the tool, specify the tool axis as ZM plus, then method as finish, then select the cut pattern as follow part. Then we have to specify the cut levels. So cut levels is nothing but in one depth, in one pass, how much material will remove. So I'm just specify the depth per cut as 2 mm and click on generate. So the software has created the tool path. If you want to see the animation, just click on verify option, click on play. In 3D Dynamics, click on play, so it will show you the material removal process. Click on OK. So in this way we have performed the first operation. Now similarly we will perform the remaining operations. Now next we want to cut the material in this inner material. Okay, so for that just again go to the create operation. Now select this type floor and wall with IPW. There are two options available, floor and walls and floor and walls with IPW. In floor and walls it will directly create the tool path from top of stock to the floor, but in this portion, in the previous operation we have cut the material up to this depth. So if you select this floor and wall, it will again recreate the tool path over this and create the material up to this. So there are unnecessary excessive time will be increases. So in order to reduce that, we'll select this floor and wall with IPW. IPW means in process workpiece, so it will automatically detect the previous tool path and create the new tool path accordingly. So it will create the tool path from this newly cutted portion to this depth. So I'll just select this floor and wall with IPW, select the geometry as workpiece, click on OK. Then this floor and wall with IPW window will open. In this you have to just specify the floor. So this I'm just specifying this is my cut floor. Again just specifying this to my cut floor. Then we have to specify the tool. So I'm selecting the end mill cutter of 10 mm diameter. Then I'll just select the tool axis as ZM plus axis. Select the method as mill finish. Select the cut pattern as follow part. Then specify the depth per cuts. I'm specifying the 3 mm. Click on generate. Sorry. So in this way we have performed the operation. If you want to see the animation, click on verify option. Otherwise click on OK. Now I have to cut this portion. So for that I'll just hide my workpiece because I don't need that now. Then again go to this create operation. Then in this again select this floor and wall with IPW. In geometry select the workpiece, click on OK. Now again we have to specify the cut floor area. So I want to remove the material up to this up to this depth. Okay. Then in automatic just uncheck the box in front of automatic walls, select the walls manually. I'm just selecting these my walls and click on OK. Then again specify the tool, that is end mill cutter 10 mm diameter. Okay. Then select the tool axis as ZM plus axis. Always specify the tool axis. If you not specify, it will automatically detect as normal to the face. Then select and specify the cut patterns. Then specify the depth per cuts around 5 mm. Then click on generate. So my toolpath has been created. Now to view that, just click on verify option, adjust the speed, then click on play. Okay, now I want to cut this pocket. So for that again go to these operation navigators and click on create operation. Again select the floor and wall with IPW. Geometry select the workpiece. I will only create the toolpath for this and I'll just pattern that toolpath up to this. Okay. Again specify the cut floor, So my floor will be up to this much depth. I want to cut the material. Then click on OK. Then again uncheck the box in front of automatic walls. Select the walls manually. So I selected this wall manually. Click on OK. Again specify the tool. Then tool axis should be Z and plus axis. Then method as mill finish. Specify the cut pattern as follow part. Specify the depth per cuts and click on generate. I am taking large cuts only because of time bonding. In actual machining, do not specify the depth per cuts more than 1 mm. It will reduce your tool life. So the operation tool path has been created. Now click on OK. Now I will show you how you can transfer this tool path to this. So for that, just right click on this tool path, go to this object, click on transform. In the motion, select the 2 point. If you know the distance between center distance between these two pockets, you can select the delta and you can specify the dimensions as per the Cartesian coordinates. But I don't know the distance between this, so I'll just select this 2 point. Specify the reference point, means from this point I want to copy up to this point. So in result, just select this copy option and click on OK. So it will automatically copy the tool path over here. So here you will find we have performed the 2 operations. Okay. So in this way we have machined the top surface. Now we have to machine the bottom surface. So for that, first we will save the model. Do not need to save the model. Okay. Now again we have to go to this modeling workbench. So for that, click on application, just select modeling. I'll just hide my clamps because I don't need that. Okay, I'll just unhide this blank. Okay, I want the same similar copy of this feature. So for that, just click on Ctrl L. For it will open the layer setting dialog box. Then from that, just select this model. Okay. So I selected this 2. Then specify the work layer number as 2. Then click on tab. Then right click on this work and just click on copy to selected layers. Okay. So it will automatically create the copy of that. So this is my copied part. So we have to transform this part from this point to this point. So for that, select these both parts, click on right click, then select the motion type as distance, specify the vector and just give the dimension here and just click on specify the move original and click on OK. Okay, so in this way we have created the copy of that. Now I have to rotate that part. So for that, I'll just create some rotation point. So for that, just click on sketch. I'm just creating this rotation point. Click on finish sketch. Sorry, okay. Just click on finish sketch. Now I want to rotate this part. So I'll just select these 2 bodies and again press Ctrl T. Then from the motion select the angle, then specify the vector. I want to rotate this along this vector, and specify the rotation point. So this is my rotation point. Specify the angle 180, result type as move origin, and click on OK. So now you can see that we have rotated the part. Okay, in this previous part we have the cuts on the bottom face, but in this we don't have. Now I want to perform the similar machining operation on this face. So only if you have the lots of operations on each of these faces, so for that just create the separate layers and do the operations. So again go to this application and manufacturing workbench. Now we have to create the another UCS on this point. So for that click on create geometry, select the MCS, name the MCS as MCS bottom, then click on OK. Then specify the MCS to this point. Then click on OK. Again click on OK. Now I want to create the separate work part and separate blank for that. So for that again click on create geometry, click on workpiece, name the workpiece as bottom, click on OK. You cannot specify, you cannot use the space bar, just click on OK. Now specify the part, then click on OK. Then specify the blank, then click on OK. Now you can see that this bottom face comes under this MCS mill, but we have to put that bottom face under this newly created MCS bottom. So just select, click and hold the left mouse button and just drag this to MCS bottom. So it will come under this MCS bottom. So whatever operation will perform on this bottom face, that will comes under this, that will select this MCS. Okay. So again click on create operation, again select the planar mill option, then in the geometry select the bottom face, because we want to perform the machining operation on the bottom face. So for that select this bottom face, click on OK. Again the planar window will open. So here we have to specify the part boundary. So similar to the previous, we select the part boundaries, so I have selected this. These are my part boundaries. I want to cut the material over this. Then specify the blank boundaries. So this is my blank boundary. Then we have to specify the depth, floor depth. So up to how much distance we have to cut the material. So I'm just selecting this as my floor. So software will automatically create the toolpath from this point to this point, and specify the cut level. So I want the fine cut, and click on generate. Okay, sorry, we haven't specified the tool. So sorry, select the tool, select the tool axis as ZM plus, and click on generate. So it will automatically create the toolpath. To view the toolpath, just go to that, select the verify, select verify, then in the 3D dynamics you can play. I have selected the larger depth cuts, that's why it is performing fast. Okay, then click on OK. Then click on OK. In this way we have performed the detailed machining of this part from the top as well as from the bottom face. Now the next step is that how we can call the actual machine tool and see the similar operation on actual machine. Okay, so for that just click on machine tool view, and from that double click on generic machine. In software there are lots of machine tools are available, so select the machine tools according to your application. I'm just selecting this. Then from positioning select the part mount junction, then specify your part mounting. This is my part mounting point. Click on OK. So we have called the actual machine tool. Now sorry. Now to view the operation, just again go to the geometry view, select the operations and click on simulate machine. Don't select verify, just click on simulate machine. Then select the show 3D material removal and click on play. So you can see that this operation is how the operation is going on actual machine. If you want to see the tool positioning, so select this show machine axis position, so it will show the machine axis position coordinates. So in this way we have seen how we can call the machine tool. Now the next is that we'll see how to create the part program. Okay, so for that just select the operations, right click, post process, select the post processor type as mill, then select the output as destination folder. So I'm just select this is a stop milling, click on OK, then click on OK. Then based on your operation sequence, it will create the part program. Okay, so this is my part program. If you want to create this part program for the bottom face, you can create in a similar fashion. So in this way we have completed this tutorial. So if you find any problem, just comment below. I'm uploading the link for this model, so that you can refer this model and you can try this. I'm uploading on the solved model also, so that you can cross check the tool paths and everything. So again in the next sessions I'm uploading the Delcam training series. In that I'm covering the power shape as well as power mean and detail. So just please subscribe to channel for the more videos. So thanks for watching.